We're looking at the diagram HLFK, which is a cyclic quad. There is the diagram HLKF, which is a cyclic quad with chords HL and FA produced to meet at M. The line through F parallel to KL meets MH produced at G. And we're given all the lengths for different sides. And what else is very important to highlight here is that we are not told that FG is a tangent. So we can't make an assumption that FG is a tangent unless we can prove it. So let's look at the first question. The first question, name two with reasons other angles that are equal to K1. Where is K1? There is K1. We know that K1 is 140 degrees. So we need to find two other angles that are equal to K1, which is 140 degrees. The first angle that is equal to K1, you can see K1 is an exterior angle of a cyclic quad. So K1 will be equal to angle LHF. So K1 angle K1 is equal to angle LHF. Present exterior angle of a cyclic quad equal to the opposite interior angle. So let's label that. We know now that angle LHK is 140 degrees. Now we need to find the second angle equal to K1. Okay, the second angle that will be equal to K1 is the whole of angle F. The whole of angle F. Why? So angle F is equal to K1. The reason? Corresponding angles. Why do we have corresponding angles equal? Because line KL is parallel to line FG. So we've got two reasons, two angles that are equal to K1. Now let's move to the second question. The second question requires to determine the size of G. Okay, if you look at the big triangle MGF, we've got only one unknown angle, that is angle G. We know M is 20, we know F is 104, so G should be 56. And the reason for that is angles in a triangle. Let's label G. G is 56. Number 3. In number 3, we require to use calculations to show or to prove that MG is 36 units. Where is MG? MG is this long side of the big triangle. The long side of the big triangle. Now, what are we going to do that? We need to use similarity. Why? Because in the big triangle, there are two lines that are parallel, which is line FG and line KL. So let's start. We will start by saying LG over LM must be equal to FK over KM. Reason? Proportionality. And then we got the two parallel lines, KL parallel to FG. Now we need to do the substitution. LG is what you're looking for, over LM is 12, is equal to FK is 20, over KM is 10. And then on your calculator you will get that LG is 24 units. But that's not what the question asks us to calculate. We were asked to calculate the length of MG. So MG is a whole length. We already know that this length is 24. So therefore it makes MG equal to 12 plus 24, which is equal to 36. Okay, now the next question we need to show that triangle MFH and triangle MGF are similar. Okay, which are those triangles? Triangle MFH, let's highlight them for you. FH and the next triangle is MGF. Now I'm going to draw MGF separately so that you can see clearly how it looks like in terms of the size of the angles. So let's draw MGF from M to G. We'll say is that line M to G, then we will draw G to F. G to F is from there to there, and we have 56 here, we have F here, and at F we know that we have 104 degrees, and at M we have 20 degrees. So two ways to show that the triangles are similar is either by using equal angles or by showing that the ratios of corresponding sides is the same. But in this case here we are going to use the angles. Okay. So our first statement will be to say that angle M in the yellow triangle is equal to angle M in the green triangle. resin, common. The next set of angles is angle G in the yellow triangle is equal to angle MFH. In the green triangle. Now, why do I say that MFH is 56? Okay, look at it carefully. We have 20 degrees, 104 degrees, and that gives us 124 degrees. So the remaining angle here, this angle here should give us 56 degrees. Angles in a triangle. Okay, so we've used M, we've used G. Now we need to use F. F in the yellow triangle is equal to H in the green triangle. Okay. F in the yellow triangle is equal to angle MHF. MHF. Okay, reason we have proved it above. So therefore, triangle MFH is similar to triangle MGF. Reason we use 3 angles. Okay, so we've done that part. Then the last part is saying we need to complete that statement, the statement here that says MFH similar to MGF, also similar. So we need to find the third triangle which is similar to these two given triangles. So let's complete that. MFH similar to triangle MGF, similar. Now we're looking for the third triangle which is similar to these other triangles. There is the triangle. I will draw it in red. In this triangle we have 20 here, we have 104 down here, so it means up here it should be 56. And you can see all other triangles, they have 104, 56 and 20, and the same thing applies here. We have 104, 56 and 20. Okay, so the next important thing is to write this similarity in the correct order. Okay, so how do we write that order? MFH is 20, 104, 56. So we need to follow that order. Let me go again. MFH is 20, 104, 56. So here we're going to go 20, 104, 56. What is that? It's MKL. Okay,